But the companies that came with data science profiles recruited our students at an average package of approximately 64 lakhs. Right? And our overall average CTC was more like 29 lakhs, 29 lakhs, right? So data science obviously is twice as lucrative as other roles, right?
Right.
Why is that the case? So in business schools all across the world, there are 4 or 5 concentrations or majors they all offer, right? Finance, marketing, product maybe nowadays, HR. But what we realized last year at Masters Union is that we had many more open vacancies and open positions in our recruiters, in data science and data analytics. And in fact, the highest package that was drawn by one of our students was also in data analytics. So what we have figured out essentially is that we need to introduce data science as its own independent concentration, its own independent major within our curriculum. So today we're going to talk to Nandini, who heads our data science department and also our academics team. And we'll delve into why data science has become its own niche field and why the best CTCs and the best opportunities are being found in data science. So to answer this question about why we should study data science as part of the MBA program, we have our founding faculty, Nandini, with us today. She's a PhD from IIM Bangalore and has worked in data science roles across the field. So Nandini, the first question that I want to ask you today, and I have so many, by the way, and that's why I have to have a piece of paper, is this, right? I mean, right now, there is so much hype about data science, data analysts. There are these millions of jobs that are vacant out there in the US and India. And even at Masters Union, we see tens of recruiters coming in to hire for data science. We'll talk about all of those things. But my question is that, I mean, what is the need for this data science expert, for this data analyst? What are they doing in a company? Why does a company need a data scientist or a data analyst?
Got it. So we will, of course, cover this in a lot more details on how a data analyst is different from a data scientist. And that's
that's different.
Oh, yeah. And that's a very important distinction, I think, that we miss out in, layman conversations. Many words get used interchangeably, which shouldn't be ideally. I want to just highlight here that, data science or analytics in general is not something that is new. Companies have had data since time immemorial, when statistics kind of was, cropping up when in 30s, statistics kind of became like a domain, was also just to analyze data of the state, which is where the word statistics comes from. And it's not like we never had data or we never worked with data, but it is of late, post 2005, that period is when we kind of understood or realized the potential of the computational capabilities that we now have, wherein we can work with data at scale. And that is where people saw a very massive opportunity for competitive advantage. They saw massive opportunities for consequential decision making, wherein they realized that now the data, which was already being generated, can be leveraged to make these decisions.
So you threw a lot of jargon. No, we'll have to start again.
Okay.
So you have to break this down for me.
Okay.
So you said companies have always been collecting data. That's great. But now companies have the computational power to do something with that data.
Right.
And that's why you need data scientists or data analysts.
Right.
So could you tell me how things have changed since 2005? How much data was being collected back then versus how much data is being collected today?
Right. So ideally, if you go back and 2005 is something that, sticks with people is because Clive Humby, who was this gentleman doing really amazing work in the data science domain, made this statement where he said data is the new oil. This was 2005. And, so many people quoted it. It was on the front page of Forbes magazine and everybody started picking on that. The idea was, firstly, the amount of data that was being collected pre-2005 versus post-2005, there has been an increase in the data as well as the velocity of the data as well as the formats in which we collect data. If you typically imagine when we were younger, I'm assuming we're the same age, when we were younger, the way we used to visualize data was in form of tables, right? The way you would say data, people would think about an Excel sheet, they will think about rows and columns. Now, when you say data, this is data that we are recording. When you scroll down on Instagram, your click stream, your browser history, everything is data right now. When you ask Alexa to do something for you, that is data for you. The formats have year on year grown so much that if I talk about 2008 and maybe per person data that was collected was about 12 GB, it has come to some 9,000 GB per person in, let's say, just 2 years after that.
Per person per year?
Per person per year.
So I'm generating 9,000 GB of data every year.
Oh no, you were generating that much data in 2010 or 11.
Oh wow.
Yeah.
Okay.
Now the amount of data that we generate, I don't know the exact number right now, but it's going to be many folds.
So every CCTV footage is probably data as well.
Absolutely, absolutely. You don't.
Every traffic camera, everything.
There are satellite imagery that is data that is being utilized now for decision making.
So today per person, how much data are we generating?
I have not checked the number, but it'll run in TBs per day.
So TBs are?
Terabyte.
Terabyte. So how many GBs is that?
So that is going to be about 1,000 GBs for you.
Okay. So as a human being today, I'm generating probably like terabytes of data every day.
Terabytes of data every day. Yeah.
Wow. And so now the data analyst's job or the data scientist's job is to make sense of this data, right?
Yes and no. So the idea is that, there are fundamentally these concepts of machine learning that we talk about quite a lot, artificial intelligence that we talk quite a lot, and then we use these more placement-oriented terms like data analytics and data science. Now, and again, there are jargons that get thrown around which are around big data and small data, high velocity data, high variety data, things like that. Now, a data scientist's job is to look at large-scale data and make sense out of this that can be utilized in business. A data analyst's job could just be about cleaning the data. A data analyst's job could just be around understanding what kind of data to collect, so making sense of that as well. Or there could be companies that are making the data analyst do a job that a data scientist is supposed to do. So it's very company specific. It is very specific to the context.
So let me stop you there. You use the word making sense of data. Give me an example of making sense of data.
Okay, to give you a very, very, so right now before coming for this talk, right, I needed to order a few books. And very frankly, I'm this go to a physical store and buy a book kind of a person. And I was almost hating on Amazon when, they used to recommend me books and they came and books could be bought online and things like that. But now I actually use Amazon's recommender system to see which books I would possibly like to read once I have read another book which is on the similar context. So recommender systems are one of the biggest examples of day-to-day making sense of data that,
So let's say I'm Netflix, right? And I have a data scientist and I'm a data scientist at Netflix, right? And I've collected all this data about you. And now I know what, I've built an algorithm that now basically recommends movies to you. So once I've built that recommendation engine, should Netflix just fire me? My job is done.
Okay, so I think it's not that simple. There is a huge difference between bad recommender systems and good recommender systems. Recommender systems in general, in the beginning, are very bad. This is something that I say to everybody who's trying to build a recommender system because they suffer from this major cold start problem, right? Most of the users on Netflix are either new users or they are users that are sharing their passwords. They are users that possibly don't have one defined kind of, movies that they like to watch, things like that, right? So you need to have a lot of data to make this recommender system. Secondly, just knowing my data will not help Netflix. Netflix has to find other people who would watch things just the way I would watch them and kind of also combine their sort of viewing patterns and then this. Netflix goes 5 steps ahead, right? So Netflix doesn't just worry about a recommender system. Netflix also makes movies on the basis of data. Like when House of Cards was built, for example, the color scheme of House of Cards, who should be kind of the director for House of Cards, the pilot, the whole placement of Kevin Spacey in the first 30 seconds of opening of this, Kevin Spacey coming out of the frame and talking to people, everything was data.
So data was the director.
Absolutely. So for example, like if I ask you how many genres of movies do you know, you would go about saying maybe, I mean, even if you're a big movie buff, you list around 20, right? Netflix works with hundreds and hundreds of something that they call micro genres.
Got it. So let me stop you there. So I really like the Netflix recommendation system. They mostly get it right. Mostly, I think. But I also use Hotstar.
Right.
And I don't even know if they have a recommendation system.
Right.
Right, because it's never able to predict my what I'd want to watch.
Right.
So is that the difference between a good recommendation system and a bad recommendation system?
Absolutely.
So what advice would you give to the data scientist at Hotstar? What more can he do?
So ideally, I think they are a little more regional when it comes to collecting data. I think their regional recommendations actually work a little better than their let's say English or Hindi recommendation systems. Maybe using a larger scale data and maybe dividing it by micro genres. So for example, I don't think Hotstar does something like this, which Netflix does, and that's why it gets it right, because Netflix doesn't see a movie which is like a chick flick movie just as a chick flick movie. It sees chick flick movie where the girl goes to college is a micro genre for Netflix. Chick flick movie where a girl marries the prince is another micro genre, and that's how they recommend
So
the system
their tagging
works.
system is a lot more complicated than just layer one.
It is so beautiful. It is so beautiful. I think it'll take days for somebody to even figure out what they are doing.
Okay, so now let's talk about Netflix a little bit more. So there's a data scientist team at Netflix that's probably optimizing this algorithm every day.
Yes.
Correct?
Yes.
What is the data analyst at Netflix doing?
So for example, now imagine this, right? The kind of data that is being collected at Netflix right now. What do you think it is? It is not just how many people are viewing, not just what region they are viewing from, not just what movies they are watching, but how long are they watching the movie? Are they switching between the two or not? Trying to understand or comprehend if two different people are using the same kind of login or password or not, even within the the same user base. Trying to figure out which new genres to bring about and how many productions to have in that. Now within that span of time, the kind of data that they are generating is so huge and so humongous that there has to be a team of people who are actually doing the data engineering bit. And data engineering is almost creating new variables, making sense out of individual variables or individual data that they are collecting.
Give me an example.
So for example, let's say I see. So if you are watching something on Netflix, like let's say it is something like a show for Netflix that is just Pratham watching, let's say, Friends. Now a data engineer will break this down as to how many hours did Pratham watch this show, how many hours did Pratham watch this genre, how many hours did Pratham watch something which was with these many people, how many times did Pratham watch this. These are all new variables that are just coming out of one data point for you. These new variables being created is a data engineer's job or a data analyst job that they do. Maybe building the recommender system and updating a recommendation the system can be given. Data scientists mostly look at the business side of things or how it will. So when I say that House of Cards was built on the basis of data, the final recommendations that were given to the production house that this is what you should do is more the data scientist's job, right? They understand the business aspects of things also. It's their job to kind of marry both of them.
So now let's switch gears a little bit, right? I think now we understand the significance of collecting data and the impact of that data that's collected and the sense that people make out of it. Now, we run an MBA program here at Masters Union, right? And for whatever reason, I was very surprised that last year, almost 30% of companies that came to recruit from Masters Union were recruiting for data analysts or data scientists.
Right.
So as I understand it, it's a technical role, as I understand it. So why are companies coming to MBA schools or to business schools to recruit data scientists and data analysts? Why can't they just go to an IIT to recruit?
So I'll have to answer this by disagreeing with you a little bit here. That your belief that data science is actually technical is somewhere incomplete, right? I'll not say that it's flawed. That's how most people perceive it. But broadly speaking, there are two kind of parallel conversations that have been happening in the data science world for a very, very long time. The one conversation is around pattern recognition, predictive capabilities, building ML models, for example, the machine learning models that we built. And the other kind of conversation that is happening with this is, yes, well, fine, you can build these models, and these models are theoretically very strong in an experimental environment or with a very clean data, but that's not how the world works. So when you have to kind of use these models and situate them in actual decision making, there are many components that are a part of it, right? There are many things around the business that you need to understand. There are many constraints around the risk.
Explain with an example.
All right. So if I were to give you an example here, let's say I work with a very clean data set around predicting fraud, right? And this was the starting point of fraud predictions and risk analytics, and a clean data set would.
So like a payments company has to figure out whether the credit card being used is stolen.
If they should give credit to somebody or not.
Okay,
as
fair.
simple as that,
done.
right? Let's not even go into the credit.
Okay, so I'm Paytm, and I have to figure out whether to give you
some credit line or not, right? And traditionally and typically these models have been in place for many years now with major companies like American Express and all these people, right? And they're very good at their prediction part, the pattern recognition part. That there are some logistical things that you will imagine that if somebody does not have a master's degree or an undergraduate degree, then the paying up capability is lesser. Or if somebody is married, they are more likely to pay on time and things like that, right? So it's easy to figure out that default. Now, bring this entire challenge or bring this entire question in context to, let's say, in an Indian context, let's say like a small or medium business where there is not enough personal history on the credit, where there are challenges related to the entrepreneurship that these people, like the day-to-day challenge.
It's more complicated to predict.
It's so much
whether
more complicated. Yeah. There is a lack of data that is provided for them. Even when there is data, it's not very clean data. There are risk appetites that are very, very different. There are paying capacities and situations that are very different. So now, even if you do get some data, do you really rely on that data as much, or do you actually position it in that context and figure out how to go about with this?
So I'll collect the data, but then I also need a business person to look at that data and make sense of it.
Absolutely.
I have to interpret the data.
Absolutely. Not just interpret the data, but also figure out if it is worthwhile to use a model. If yes, then which model is it worthwhile? The data analyst will run the model. This person who has an MBA or who has a broader understanding of business will actually tell you if there is actually merit in solving that problem. And if yes, what kind of data should I collect? What kind of decisions should I make on that data? What kind of things to do, right? I can build a model that tells you whether you're going to have a heart attack or not. Will you trust that model, or will you go to a doctor?
I'll go to a doctor.
Right? So you're in the second stage, is why you need business students knowing data. That's why you need them.
So the way I'm thinking about this is that, if I go to a contractor and tell him, go, please build my house, right? He'll hire a plumber, he'll hire a electrician, he'll hire someone to, lay the bricks.
Right.
But there is nobody to sort of bring everybody together, and that's why you need an architect.
And that's why you need a project manager.
Okay.
That is where you need a project or a program manager, right? Because that becomes a part of that. But here's something where a data scientist or data person will tell you. The person will tell you where to locate your house, which will be the most optimal for you, which will be closer to work but enough away from the city or things like that, right? So the point is, data is now being used in all of the domains. So like you were saying, a plumbing guy, somebody, electrician and things like that, these are different verticals. So typically, if I look at any organization, the fundamental verticals are finance, operations, marketing, and then the human aspect, which is the HR. There are 4 fundamental verticals. Data can be a part of all of these verticals. So it's not like a 5th vertical, but it is almost like a very, very strong toolkit for all of these 4 verticals to function better.
Got it. So a data scientist, if I were to hire a data scientist to help me build my house, he would tell me, what is the most optimal way to locate my bed, right?
Yes.
Or he'll tell me, out of all the beds that I have studied, if you position your bed at a certain angle,
possibly.
So that's the reason I would hire a data scientist to build my house.
Yeah, if you hire a data scientist.
I wish I will not, but I get the point. Awesome. This is very interesting. So your point is that you need people with a business perspective, with a business background,
Absolutely.
to come in and mix or to figure out whether you even need a model.
Absolutely.
And then if we need a model, then which model we need. And then you also need somebody to interpret that model.
Exactly.
And so while a tech person can build that model for you, the before and after of building that model has to be done by this data science or data analyst person who ideally should have a business background, or in our case of discussion, an MBA.
Yeah, exactly. So that's what I tell my students in the class all the time, right? And for the record, I teach these courses here at Masters Union. A job for an MBA who is actually, data-sentient, if I may, is not just to build the models. They are often they often question whether they will find the right jobs and all. And my point is, a person who is like an executive level person just has a business problem. The person will come and just tell you, listen, I'm not able to sell my product. End of story. How do you convert that business problem into an analytical problem? Then you solve that analytical problem, and then you convert that solution into recommendations for your business.
Correct.
Is that entire journey that a person who is skilled at both business and data would be able to make, which I don't think somebody who's coming purely from a tech background will. They will take many years to learn that. They'll take many years to understand business.
So last year at Masters Union, I was looking at our placement data, right? And we had consulting companies come and recruit at a certain package. We had marketing firms come recruit. We had startups come recruit at a certain package. But the companies that came with data science profiles recruited our students at an average package of approximately 64 lakhs. Right? And our overall average CTC was more like 29 lakhs, right? So data science obviously is twice as lucrative as other roles, right?
Right.
Why is that the case?
Because it's hard. It's simply put, it's hard, and the number of people that have the requisite skill set are very low in the market right now. So data science, as we speak, right, and see, data science has a foundational underpinning of statistics and optimization theory. It is almost to say that, if I can give you a very small example, right? How so Maxwell gave these electromagnetic equations and everything, and people have known them for a while, but it took some time to build circuits. It took some more time to bring electricity to
semiconductors.
Exactly, semiconductors, and to ensure that it is safely provided to people at scale. Right, so it was actually the theory of electromagnetics, and then building on top of that was electrical engineering, and so on and so forth. Similarly, statistics and optimization theory is that foundation on which, when you build that engineering, which comes from a good understanding of computer science, it comes from a good understanding of coding, it comes from a good understanding of databases in general, is what becomes, let's say, a machine learning algorithm. And when you situate it in business is what becomes data science. And now these are many requisite skill sets that individuals need to have before they can actually go and claim that they are experts on data science, which is why the pool is very low, and therefore, it's a simple demand and supply thing in that case.
So, I mean, there are not a lot of MBA schools or business schools where they teach data, right? I mean, it might be an elective here and there, but I'm sure it's not as important as, let's say, marketing or finance, right? But here you have insisted again and again that data science should be its own concentration.
Absolutely.
Right. So what has been your experience teaching data science? Are students receptive to it? Do they understand How do they appreciate
Right.
how data science will be applied in the future? Are they excited about it? Because a lot of people come to business school running away from math,
Yeah.
running away from stats, running away from engineering.
Right. I think fundamentally where we go wrong with this fear of statistics or that anxiety related to statistics or numbers is because of our early age education and how it is not maybe properly done. And I'm not saying this is country specific. This is a global issue that happens, and therefore I think over period when we grow, we kind of develop this fear of numbers and everything. Whereas in my opinion, I think statistics is save a few theorems which are counterintuitive. Everything is so intuitive that I don't even know why people are so scared of it, right? And
Because you're good at it.
no, not really. I wasn't. I actually failed math in 6th standard. That was the
I
only
don't believe
subject
that.
I did. I can show you.
Okay.
I developed my love for maths over time. We've had a love-hate relationship. But yeah, so
That's why you married it.
yeah. So almost they are kind of, it's a mix of excitement and this, but how I try to kind of frame my courses and how I think a lot of courses at Masters Union are framed are not, for example, you're absolutely right, marketing is important, but so is retail and marketing analytics. So we first teach them marketing and we then bring them to understand what is marketing and retail analytics and what are the kind of tools that you can use, what are the kind of problems that you encounter in that domain, and how do you go about you may not be able to solve them in the course, but how do you go about structuring your solution space and so on and so forth. So I think over a course of period, I see that they, like when we introduce it to them in the term 2, term 3, they're a little scared, but over a period of time is when they get more comfortable with coding. They kind of start seeing merit and value.
Let me stop you here. So someone who is in a business school, and of course, we are recommending to them that you should study data science.
Yeah.
Right. That goes without saying. But do they need to code?
Right.
Do they need to know how to code?
That's a wonderful question. No, not necessarily. I would recommend they do. And that's what I like my students to say, that if you can do the job 2 steps under you and 2 steps above you is when you're in a good position. So you should know how to code. You should know how to review codes and understand what somebody is doing.
So that means my undergrad has to be in engineering, right, or in computer science?
No, not even a little bit. Mine isn't. I was a math grad. Never studied any form of coding in my undergraduate level, but I still code in pretty much all languages that I know right now, which are statistically.
But you are also a PhD, so of course, I mean, you're not a great example.
No, I learned this before I joined my PhD program, because you kind of realize that that it is important, and when you see the magic happen is when you also get interested. So while to answer your question, is it necessary? My answer would be no. Do I recommend it? My answer would be yes. There are also very many low-code platforms now that one can utilize.
What is low-code?
So essentially, you don't really have to write the code per se. They could be plug-and-play where you can do. There are websites that can run machine learning models for you. And I would like to just emphasize here that I'm particularly using the term machine learning instead of data science, because that I'm trying to say that they will only be able to run the model for it. The business insights you will have to. And when you marry it together, it will be data science.
Got it. So let's play a game.
Yeah.
Okay. As you mentioned, that data can be used, or a data science or data science can be leveraged in each of the departments in a company, right? So let's say we are Amul.
Okay.
I don't know why I picked up Amul, but let's say we are Amul. And Amul has a marketing department, it has a production department, it has a finance department, it has a sales department, it has everything, right?
Yeah.
So I'll name a department, and you have to tell me how that department at Amul leverages or should leverage data.
Okay.
Fair?
Yeah, fair.
Fair, okay. So let's start with marketing.
Okay. Marketing is very simple. I mean, marketing, they can actually look at data of individuals, like for example, your market basket data as to individuals buying certain items and be able to figure out what Amul items they're going to buy. And that is going to feed into operations because that will help them.
We come to operations.
No, but that feeds into operations also.
So that's how marketing data can help the ops team.
Ops team
Okay,
also.
got it.
So they can, so from that perspective, they can figure out what pricing should be the right pricing, what promotions they should be running. If people actually tend to buy more during promotions, then you figure out that this is a chunk of my audience that is actually a price sensitive audience, and therefore I need to give them discounts.
Okay. So big application in the marketing department of data would be setting and optimizing the pricing.
Pricing, promotions, also in advertising strategy, you might be able to figure out what kind of advertisements are doing better when you put them, which actually marketing mix models.
But that though the Google Analytics will tell me, why do I need?
Google Analytics is just one form of, your medium of marketing. You could be doing the same ad on radio platform. You could be doing the same ad on TV. You could be doing the same ad on banners. You could be doing the same ad on, let's say, during using Google. So now, how do you optimize? If I have 100 rupees, how much money should I actually be spending on Google versus how much money should I be spending on television versus how much money will be very dependent on the company that we are talking about, the product offering that we are talking about, and that leverages something called marketing mix models, which are also.
So then if I'm a business student, I should, and if I want to do this job, then I should study marketing on one side.
Right.
And then I should also take some data science classes.
Right.
And then if I marry the two, then I'm that much more valuable to the company.
Oh, absolutely. I mean, from the standpoint of a company, imagine like you are working for an Amul, sales and marketing, for example, even positioning your product on the shelf in a particular mart is something that requires data science, right? And where should you position it? Where would it sell the best?
Do you think Amul is doing that?
I don't think so. A lot of Amul especially can do so much more, right? Because they have a perishable product, and that is a domain that is still very, very underexplored in the, like, how would you leverage an algorithm to understand how much to produce so that you don't have wastage, and because you have perishable products. I don't think a lot of companies are using they've gone that far.
It's only the SaaS companies and the software and the tech companies that have started leveraging it.
Yes. Also because the kind of talent pool that they have, it's easier for them to adopt these kinds of things. Also because of their executive level people have trust and faith in data-driven decision making. Herein, what we see is there are a lot of companies, there are a lot of executives that take the decision and then just use data to validate that decision.
Themselves.
And if it goes against, then they might have a conversation, or sometimes they will completely not use the data at all.
Got it. Finance.
Finance again. So pricing is one component where finance can be using it. They could also be using this data, which is the sales data, and be able to make kind of an entire yearly plan of how much to produce, and that can be coming in from.
So financial planning can be done on the basis of
financial planning. Actually, for a lot of companies like Walmart and Macy's and all, I've actually worked with the team that did this for Macy's, where they kind of used data to figure out what kinds of style would come in vogue next year, and then.
No, let's stick to Amul.
Okay, so for Amul, I mean, they can do the production planning accordingly, and therefore the financial year planning.
I guess they can also figure out, right, like which sort of cows to invest in.
Okay.
Right? I mean, because their production is dependent on the cows, right? And I'm sure there are multiple varieties of cows.
Yes,
right?
yes. And also like what to feed and how much area to give them for grazing and all that. Yes, these are questions that can be answered using data. But then again, when you kind of introduce living beings into the system, then you kind of have to go the second route where you understand the interdependencies.
Okay, I think I took it too far. I took it too far, clearly.
Maybe.
Even like, for example, collections, right? I mean, they have millions of retailers, and which retailer is not paying back, which retailer is delaying payments, which retailer, and what is the behavior, and can we
in fact, where should you set up your warehouse, which retailers, like what spoken hub model you should be following, if there is actually a need for new Amul parlors in a certain locations. Those kinds of questions again are sort of somewhere in between the finance and the operations side, but yes, how can they optimize their supply chain in order to make sure that, you know, when there is a product that is needed, it's absolutely there on the shelf, but not too much of it. So the optimal product mix that they should have, in fact, those kinds of things, quality checks, quality assurance, everything is right now driven by data. At least the quality side, I'm sure that they are still leveraging quite a lot of data. Yeah.
Got it. So you know, I think a couple months ago, we had someone very senior from Amul come in, right? And they told us that currently their revenue is approximately 45,000 crores. And their target is that every year they have to increase their revenue by at least 10 to 15%.
Okay.
Right? So that means they need 4,000 crores. They need 4,000 crores more next year. So if you are a data scientist, how can you help Amul and the CEO of Amul, let's say, help him get that marginal 4,000 crores?
Let's see. I think, yeah, I'd go back to the point that I made, that it's a perishable product. So I will first want to realize how much. So there are two things. For example, they first might not be producing too much because they don't want that much wastage. And secondly, they might be losing money because there is wastage. And there could be the third point where there is actually potential market that they are not exploring. So maybe a combination of all three would come in from figuring out exactly how much demand would be there in the, in particular markets, and maybe going that route. Would be helpful. I think with perishables, that is what will be the next big thing.
Got it. So, I mean, there's this company called Mu Sigma that I keep hearing about, right? What do they do? I know it's a data consulting firm.
Right.
So it's basically, when I don't have data analysts in-house, do I just go to them and rent data scientists from them?
Right. So it's not just Mu Sigma. There is Absolute Data. There is Accenture AI. There are now the big MBBs are also building their knowledge centers in such a way that they can do more data science consulting rather than just management consulting. And you exactly do that. For example, the example that I was giving, if I have 100 rupees, where should I place those 100 rupees, what kind of marketing mix I should have, things like that. You may be a very small firm, or you may be a firm that is more a manufacturing firm and does not have the right in-house capabilities. You can definitely go up to them and they might be able to figure it out for you.
Got it. So you mentioned McKinsey, right? And this is something that I've heard, being spoken in the hallways here, because the BCG head office is right upstairs, is that management consulting at Bain, BCG, McKinsey, EY, all of these companies, very quickly is transforming from just consulting to essentially data consulting. Is that true? I mean,
it has to, right? It has to. See, I have massive amounts of respect for management consultants because they go into an office and figure out somebody's. I didn't say that. They figure out somebody else's business better than those people do. Whether they really do it or they don't do it is something that I would never know. I never worked in a management consulting firm. But now, tell me this thing that, if I have, this is an educational institution, does the way this educational institution work similar to how another educational institution works? Not really. The kind of students that are coming here, are they going to be same as the other students? No, maybe similar, but there will be differences. And we are getting into this zone where solutions have to become hyper-personal. They're not even personal anymore, they're hyper-personal. I should not be just, we want to reach at a place, and by we, I mean the community in general wants to reach at a place where I'm not building a model that kind of says something about just people like Pratham. I want to build a model specifically for Pratham, right? And the same goes for business solutions. Every business problem is different. It may not be novel, but it is different in some ways, and therefore the solutions have to be different. The data around it is different, and now you have that collected data. Do you really want to ignore all of that data and trust maybe a few matrices and be able to make those decisions? I doubt that people are willing to pay for that.
Yeah, because anymore. I mean, last year what happened was, when the BCG interviews were going on, I remember, I think one of your students, she was asked a question about Python in her interview.
Yeah.
And I mean, lucky for her that she had done Python as part of, I think, one of your courses.
Right.
But is that become the new normal?
She is actually working on a very heavily data-dependent project right now at BCG.
Really? Okay.
Yeah, her project is completely a data science project. I spoke to her a week ago, and she's working completely on a data science project and making recommendations to the business. Of course, her team now combines data science consultants and management consultants to blend the two together. But standalone, I don't think management consulting will see a lot of business being generated. In maybe not, maybe in the recent future, yes, but
they'll have to marry the two things together.
They absolutely have to. They absolutely have to.
So would you say that like an easier way into MBB is to just become a data scientist?
Right now, yes.
Oh wow, okay. That's a very big statement that a lot of people are going to comment about.
I stand by what I say.
Awesome. I have this question, right? That a lot of people who are watching this are probably either MBA students or want to do their MBA. They are still scared of coding, right? They're still scared of math behind data science and data analytics. And they'll probably feel that all these Python classes are going to be super boring, right? All these probability classes are going to be super boring. And they'll have to go through this entire like high school type of math,
right?
Problem statements and problem sets and whatever, right? So how do you teach data science in a way that it's actually interesting for the folks?
Okay, so I'll give it to you in two sort of. So for example, when you have to teach somebody statistics, I think, when you teach statistics at a more foundational level, like school or even at an undergraduate level, you're trying to have them wrap their head around the concepts, but also the philosophies. You'd want them to have that kind of a depth and that kind of reproducibility where if they were given a question, they're able to solve it. I don't want to do that with my MBA students. I want them to learn what they require to build a machine learning model over, right? For that, do I believe that the fundamentals are necessary? Absolutely. They have to learn those things, but those things can be packaged and delivered in a different way. For example, to give you context, I play cards in my first class, right? So I go into my class on probability theory, and instead of just writing, okay, you toss a coin, what is the probability, all of
that's
that.
That's how I learned it.
Yeah, so that's not what I do, right? I take a deck of playing cards and actually play cards with them, and maybe a hand of poker or something, or explain to them how probabilities are calculated in blackjack and things like that. And that's where you go from. And in that manner, the student kind of picks up, because again, to teach to a 17-year-old, their brain and how the brain learns is very different from when I'm teaching like a 27-year-old who has already seen a lot, and there's a lot of unlearning that is required before the learning can happen. So these kind of things stick also, and then they kind of grasp also. On the data science front, for example, I gave them one of these guys like a hackathon thing. Our final exam was basically like a day-long party. We spent 12 hours together in a room. There was a problem statement, there was data without any solution, and they were supposed to solve it.
What was the problem statement?
So it was an agri-tech problem where they were given data on weather, and they were given data on land conditions and things like that, and they were supposed to make recommendations on what crops should be grown in these particular farms. And we spent that entire 12 hours together, ordered pizzas, had some fun, put some music on, and the whole idea was just to figure that out. You had to solve that problem, and the problem was then shared with people, like the solution was then shared with people in the industry, and they were supposed to kind of rank people on how good their solution is, and that was their assignment.
Oh, so the industry basically figured out who got it right, who got it wrong.
Yeah, I was not the one. I didn't even ask them to submit their codes. They were just supposed to submit recommendations based on the codes and a report based on the codes. So their codes are on GitHub, but their recommendations are with the industry, and they kind of got
it. So what I'm hearing is that to make it a little bit more accessible to perhaps people who have not done coding before, you make it less intimidating.
Absolutely,
right?
Absolutely.
And by doing these things with cards, or
it's actually not that intimidating. I don't know why people. It's just about formal logic. That's once you understand the logic, and that's the beautiful part about coding, by the way. If you understand one language properly, you will be able to learn
our
all
program
languages.
is 1 year long.
Yeah.
Right. In 1 year, let's say 6 months towards the end have to be spent on learning the application. So the first 6 months is enough to learn Python or whatever R.
I think so. I think if one sets their mind, they can learn it quicker. I do believe that if it takes a while to bring that expertise, because as you practice more, you get, your codes get finer and finer. The first code would possibly not be a very optimized code, and they will have, if something can be said in 20 lines, it would be said in like 40 lines of code, and that is okay. Few other components that I do is sometimes I actually give them my codes with mistakes and ask them to just correct the mistakes, and they don't have to write the code from scratch. I give them a code that I messed up on purpose and then ask them to solve it. Sometimes I make them write codes and then switch codes midway. And like, for example, I know that this is the model I have to build. I'll let you build it halfway through, and then I have to work on Pratham's code, and Pratham has to work on Nandini's code, figure out what has been done so far and continue there till the end point. So there are all of these interesting things that you can do to make learning fun and quicker in terms of in terms of absorption.
Got it. So, I mean, one thing that I've understood is that, data science has application in each department. In consulting, if you're the CEO, if you want to start a company as well, you have to understand this, right? So it's become more of like the new math, essentially. Can I say that? Like, it's something that's relevant to every department, right? So, we used to say that coding is the new math.
Right.
Can we say, like, essentially data science is also the new math?
I would love for it to be. I would love for it to be. But yes, it's a lot more at times and a lot less at times. So in a way, it is something that has added a lot of value to all these departments. It has added a lot of value to all these decisions that are being made, and it is built on a lot of fundamentals from maths and probability and statistics. So yes, you may say that it's an extension or like an engineered version of mathematics and statistics in reality. Yes.